Hello students, this is Indrani ma'am from Rasayan. In this lecture, I am going to explain some important points on electrophiles and how to decide which species is electrophile and which is not. Now see, in organic chemistry, we have seen substrate or reactant reacts with reagent to form intermediate or transition state or both, and from this we will get product. What is substrate or reactant? On which reaction is taking place? Reagent, by using this we can carry forward the reaction. Now in organic reaction, reagents are of three types. One is electrophile, another is nucleophile, another is radical. So our target in this video is electrophiles only. Now see, electro means electron and philes means loving or attracting. So what are electrophiles? Electrophiles are species having love or attraction or affinity for the electrons. So these are also called electron acceptors. Since these are having attraction for the electrons, so electrophiles are electron deficient species. These are either positively charged or neutral. Now see, electrophiles are represented by E plus. Here plus is there, but electrophiles may be positively charged or may be neutral, but this is how to write electrophiles. Now see, a particular site of an electrophile is electron deficient, and that site is called electrophilic site. Electrophilic site. Now we have seen electrophile accepts electron. We also know that Lewis acid accepts lone pair of electrons. So we can say Lewis acids are electrophile. But all electrophiles are not Lewis acid. We will see example. Another important point you should know, since electrophiles accepts electrons, that means itself it is reduced. Since it is accepting electrons, so this is oxidizing agent. So electrophiles are oxidizing agent. Now see, electrophilic sites are of following types. Number 1, they may have positive charge. Examples: H plus alkyl cation, CH3CO plus, Br plus, Cl plus, NO plus, nitrosonium, bromonium. This is bromonium. This is chloronium. This is nitrosonium. Then this is nitronium. Nitronium. Everywhere these are having positive charge. Now remember, all positively charged species are not electrophile. To be an electrophile, the central atom should have positive charge and at the same time it should have vacant orbital or incomplete octet. Now one by one see, H plus, proton. Proton, here positive charge is there and it is having vacant orbital. You know, hydrogen means its electronic configuration is 1s1, and for proton s orbital is vacant. So here it can take electrons. So it is having vacant orbital. Here also see R3 plus, simple R3 plus, simple alkyl cation means this one. It is having positive charge on carbon and it is having how many electrons? Complete structure is this one. 3 sigma bonds are there. So 1, 2, 3, 4, 5, 6 means 6 electrons are there. Octet is incomplete. That's why this is electrophile. Here also you can see incomplete octet is there. Bromonium ion. Bromonium ion means this one. So here you can see incomplete octet. Chloronium also it is having positive charge and incomplete octet. Now see in nitrosonium ion, between nitrogen and oxygen, nitrogen is less electronegative. So it is the central atom. So central atom is having positive charge and also here incomplete octet is there. 1, 2, 3, 4, 5, 6. Or you can say this nitrogen is having vacant orbital. That's why it is acting as electrophile. In also central atom nitrogen is having positive charge. It is acting as electrophile. Now check H3O plus is electrophile or not. It is positively charged species. On oxygen positive charge is there. H3O plus means this one. Here positive charge. Now see, oxygen is having 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons in valence shell. Means complete octet is present here on oxygen. Therefore, it is not electrophile. Because to be electrophile, it should have incomplete octet or vacant orbital. Now see, here it is having 3 bond pair, 1 lone pair. That means sp3 hybridization. So there is no vacant orbital, no vacant orbital. From this viewpoint you can say it is not electrophile, or you can say here complete octet is there on oxygen. Therefore it is not acting as electrophile. Similarly, NH4 plus ammonium ion. Here also positive charge is there on nitrogen and it is not having any vacant orbital, and also octet is completed here on nitrogen. How many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 electrons are there in valence shell. So here incomplete octet is not there. Octet is completed. And here there is no vacant orbital because nitrogen, oxygen all are period 2 elements. There is no d orbital. Okay. So that's why it is not an electrophile. So remember, first check positive charge is there or not. If positive charge is there, then check vacant orbital or incomplete octet is present or not. Next type of electrophiles are this one. They may have less than 8 electrons in the outermost shell of the electrophilic site. Means they are having incomplete octet. For example, BF3, LCl3, ferric chloride, beryllium chloride, etc. These all are Lewis acid. As we have studied, Lewis acids are acting as electrophile because they are having incomplete octet. In BF3, if you think about the structure of BF3, how many valence electrons are there on boron? 1, 2, 3, 4, 5, 6. 6 valence electrons are there. So it is having incomplete octet. That's why it is acting as electrophile. Same thing aluminium chloride, same thing. Now for ferric chloride, we know iron 0 means 3d6 4s2. Here oxidation state of iron is +3. So its electronic configuration will be 3d5. Remove 3 electrons from here. Actually, this is 3s2, 3p6, 3d5. So, how many electrons? 13 electrons are there. And in ferric chloride, it will get 3 more electrons from 3 chlorine. So, total we are getting 16 electrons. That means it is less than 18 electron. So, less than 18 electron. Therefore, it is having incomplete octet. So, it is acting as electrophile. Beryllium chloride, same thing. It is having incomplete octet. Now, next type of electrophile is this one. Suppose carbon dioxide. Here pi bond is present between two atoms of different electronegativity. Carbon and oxygen are having the electronegativity difference, and in between them pi bond is present. So what will happen in presence of nucleophile, suppose OH minus, since it is more electronegative, electron density of this bond will be shifted in this direction. So this carbon will be delta plus and carbon will be delta minus. So nucleophile will attack there. That means this is acting as electrophile. Actually, in carbon dioxide, carbon is not having any vacant orbital because it is having 1, 2, 3, 4, 5, 6, 7, 8. But in presence of this reagent, it is acting as electrophile. Similarly, in this compound, carbon is not having any vacant orbital 1, 2, 3, 4, 5, 6, 7, 8. Octet is completed. But in presence of nucleophile, what will happen? Since here pi bond is there between two atoms of different electronegativity. So what will happen? Since oxygen is more electronegative, electron density will be shifted in this direction. This center will become more delta plus and this center will become delta minus, and nucleophile will attack there. This center is acting as electrophilic site. Similarly, sulfur dioxide and sulfur trioxide are acting as electrophiles because see, first of all, sulfur is having vacant d orbital, and secondly there is pi bond between sulfur and oxygen, and sulfur and oxygens are having different electronegativity. So electron density can be shifted towards oxygen, and that sulfur is electrophilic center in both sulfur dioxide and sulfur trioxide. As we have seen, Lewis acid means it can accept lone pair of electron. So all Lewis acids are electrophile because these are electron acceptor. What is about free radical? Free radical is acting as electrophile. This is methyl free radical. Now see, it is acting as electrophile because it is having how many electrons? One, two, three, four, five, six, seven. 7 electrons are there. So here incomplete octet is there. That's why it can accept electron. So it is acting as electrophile. But methyl free radical or free radicals are not Lewis acid because to be Lewis acid it should take 2 electrons, but here it will take 1 electron. That's why to be Lewis acid it should take lone pair of electron, but only here it will take only 1 electron. So it is electrophile, but it is not Lewis acid. It is not Lewis acid. So all electrophiles are not Lewis acid, but all Lewis acids are electrophile because Lewis acid will take electrons. Now carbene, see carbene. It is having how many electrons? Each CH bond is having 2 electrons, 1, 2, 3, 4, 5, 6. So carbon is having 6 electron in valence shell, so incomplete octet. That's why it is acting as electrophile. So in this video till this, if you like, please subscribe. Thank you for watching.